Okay. Hello everyone. Good afternoon, good evening, wherever you're joining us from. Uh, Very excited to be here today. Very excited to moderate this event. My name is Faidat Badamasi. I'll tell you more about myself as we progress with the session. Uh, so today we are going to be talking about chemistry. I know some of us in the room are not like chemistry students, but I'm going to let you know that whatever we discuss here is going to apply to you, whatever field that you're in. So please just stay with us for this 1 hour, and we hope you would find this session as helpful as possible. So just a brief outline of what we're going to discuss today. So we're going to have an opening remark by one of our outstanding and amazing lecturers at Department of Chemistry in University of Ibadan. And then we go right into the theme topic, which is chemistry, the central science connecting all disciplines. I didn't mention it before I started, but please, everyone, make sure that you are muted so that we can have a fun session, So, yeah. Um, as I was saying, and once we have that, we have a very short Q&A before we go right into the panel session where we discuss pursuing advanced degrees in chemistry, master's or PhD programs. And we'll take a closing remark by our SCSN UI president, who has been an integral part of putting this webinar together. We need to, sorry about the background. Okay, yeah, I think we are good to go now. Okay, you have technical things here and there every time. So like I mentioned, my name is Faidat Badamasi. I'm a first class graduate of industrial chemistry from University of Ibadan. This is a few points about me. I got numerous awards during my undergrad at University of Ibadan, and I proceeded to University of South Carolina to pursue a PhD in organic chemistry, and I'm currently a PhD candidate in organic chemistry. And my research focuses on designing and synthesizing small molecules that assemble into supramolecular systems to give functional materials. And aside science research, I really enjoy volunteering. I enjoy academic engagements and external collaborations like this. So that's why I guess you're seeing me here today. So the next thing is to actually open up the session with an opening remark from Dr. Alimo Alabi, who is an outstanding lecturer at the Department of Chemistry, University of Ibadan. And beyond being a lecturer, she is, if I am allowed to use the word mother, I'm sure most of us on here on this call that have interacted with her one way or the other, we know that she is like a mother, she's a cheerleader, she's a supporter, she's someone who pushes you to keep going. Like you can really achieve so much as long as you set your mind to it. So I'm very pleased that she's here today to join us and talk to us. Dr. Alabi, you have the floor.
Good evening, everyone. Thank you, Faidat, for putting this program together. And I must appreciate the SCSM president too, who deemed the fit to gather everyone together under this platform. Can you all hear me?
Yes, ma'am.
Can everyone? Okay. I'm not in UI at the moment. I was rushing back from a party. I know if I have to get to UI, I will miss the webinar. So I stopped over somewhere to attend this meeting. I want to appreciate Faida Tawa. And Emmanuel, who will be speaking to us this evening. And I want to be every one of us. Not only the one thing that I can see do with my chemistry, and there is nothing on earth that is important that we try as much as possible to be attentive to see what we can pick from this meeting. And I want to assure you that you are not going to regret anything being part of this meeting. And of course, I gave you a brief intro to analytical chemistry, telling you the scope of analytical chemistry and all of that. That's just to give you a brief idea of some of the things you can do with your chemistry. And I believe that the speakers tonight will be able to tell you more about it. And I want to welcome each and every one of us to this meeting. Make the best use of the time. Try as much as possible to get as much information as you can get that will be of help to you. And most importantly, the chemistry you are learning, you don't keep to yourself. Information you have, you don't keep to yourself, because as you help your brother to grow, so will you begin to grow too. You have information, learn to share with your friends, learn to share with your colleagues, so that together we all can grow and be better off for it. Thank you so much.
Thank you so much, Ma. Just
Thank
like
you,
you
Faida.
said, it is important to actually always share information amongst yourself. Don't try to keep, I mean, they say the sky is big enough for everyone. And I feel like the best success story is when you and your friends are actually growing together. You know, if you get an award or something now, and maybe you didn't share it with your friends, they didn't try to apply, you won't even be able to celebrate it in the open. You're just going to keep it to yourself. But if everyone is growing together, I think it has more impact. So please always have that in mind. And before we go right into it, I got a notification that some of our professors at UI are currently on this call too. I just want to say thank you so much for joining us today. I cannot really see the participant list right now, but I just want to say thank you so much. We really appreciate all the investment in knowledge that you've done, and while we were back in UI, and you're still doing right now. So then we're going to go right into it now with our first speaker. So just like the topic says chemistry, the central science connecting all disciplines. And trust me, it is the central science. I mean, why do you think you have to do chemistry in high school? And you still have to do chemistry when you get to 100 level before you even go right into whatever you got into the university to study. It's really the central science connecting all discipline. And today we have an amazing, outstanding individual. I cannot find the words to describe him. He is a mentor, he is a brother, he is a friend, he is everything and more. Dr. Emmanuel Ogunkole. I just had to sort of find a way to put everything about him on this slide, but that's not possible. There is so much more about him. But just to highlight a few, he obtained his Bachelor's of Science degree in Industrial Chemistry from the University of Ibadan, Nigeria. And in August 2016, he began his master's degree in Tennessee Tech in the USA here, where he studied in the lab of Dr. Andrew Calenda. And in summer 2018, he realized, oh, I need to do more. I can make more impact. So he wanted to, oh, I think I jumped it. In 2018, he completed an internship at BI. I really cannot pronounce that. It's a German word, I think, in Connecticut. And this internship experience broadened his perspective, yeah, and further honed his analytical skills. And in 2019, he enrolled in the Department of Chemistry at Florida State University, where he joined the ROPA laboratory. And his PhD work focused on developing separation methods to probe small molecule functions in pancreatic, all of that. And then during his PhD, he interned at Eli Lilly and Company in Indianapolis, Indiana. during the fall of 2022, applying his analytical skills to contribute to Eli Lilly's expansive small molecules portfolio. And then he received his PhD in analytical chemistry in December 2023. Currently, he's a senior scientist in the vaccines AR&D separation and biochemical analysis group at Merck in Pennsylvania, if I get that right. And in this role, he's developing chromatography-based methods to support vaccine development. So, Dr. Ogunkunle, we want to say thank you so much for giving us your time today to come and talk to us about chemistry. I mean, I do not know anyone else that could do justice to this topic. Looking at your profile alone, I am already inspired. So if you're in this session, I believe you already have your notepad and your pen, and you're going to be taking a lot of notes down. So if you have, as we proceed with this session, if you have a question, please just put it in the chat. We're going to get to it during the question and answer session. And so I'm going to stop talking now and let Dr. Ogunkunle have the floor.
Wow, thank you. So I need to share my screen. Can you all see my screen?
Yes, we can.
Okay. So I need to hide this. Give me a second. Okay, great. So yeah, thank you for the opportunity to speak to your students, about chemistry. I'm honored, and I hope I do justice to the topic. And so you have, oops, this thing's not working. Okay, so you've already gone through my bio, so I'm not going to bore everyone with repetition. But one thing I really want to highlight here is that I am from a humble background. So I'm from Shaki. It's in the northern part of Oyo State, and I did all my primary and secondary school education in Shaki before moving to UI. And in 2010, I applied to study pharmacy. As a young student in high school, we all aspire to study those professional courses like medicine, pharmacy, engineering, and the likes. So it was pharmacy that piqued my interest, and I applied to UI, but UI happened, so I didn't get into pharmacy. So chemistry was my second choice. But I loved chemistry in high school, so I was the best student in chemistry in my class, and it was not like a fallback plan, but I really loved chemistry, so I didn't regret studying it. So, and then that journey has taken me from UI to the United States. I came to the US 8 years ago, and in those 8 years, I've been able to, I would say, accomplish a lot. By my own standards, I should say, I've obtained a master's, my PhD. I currently work in pharma, and I decided to add these logos just to show you my journey from UI to Tennessee Tech to Florida State, and the companies that are studying chemistry has afforded me the opportunity to work for. So currently work at Merck, but I've been to Lilly and Boehringer Ingelheim in Connecticut. So I'm going to start by UI to the world. That's what I say a lot. So I'm going to start by introducing these. We all know that chemistry is the study of matter, right? Its properties, applications. But when we're in school, it was mostly about the theory of chemistry, like the basics and the background of chemistry. But one thing that a lot of people struggle with is what can you do with your chemistry degree? In Nigeria, I would say there are limited opportunities. Maybe you can get into oil and gas, you get a high-paying job. But outside of Nigeria, I can assure you that chemistry is well sought after. And I added this picture for you to see how chemistry is connected to other majors. So you have biology, you have biochemistry and medicine, which I'm going to group together because I feel like they go hand in hand. And then we also have like environmental science, which I believe is something that is big in Nigeria. And then we have physics, like engineering, geology, and the likes. But due to the short time, I've decided to just group this into three. So I'm going to be talking about how chemistry is related to like medicine generally, and environmental science, which is something that I really have passion for, and also material science and engineering. And then I'm going to be keeping like my own story, you know, how chemistry has brought me to where I am today. So in 2011, when I started at UI, 100 level first semester, Professor Oshibanjo actually was the person that gave this kind of lecture. It was during the fresher orientation, and he told us his life story, you know, how analytical chemistry has really helped him to build his profile and the kind of opportunities that analytical chemistry afforded him. So like I said, I currently work in pharma, right? So I feel like this is the best place to start. You know, with your chemistry degree, what can you really do? How does chemistry relate to biology, to medicine? And we know that drug discovery or the discovery of new medicines, arguably the biggest contribution of chemistry to human life. So in those days, our forefathers relied on herbs, you know, from trees and the likes, and we know that there are adverse effects to things like that. Like millions of people have died from different diseases in the past. Spanish flu of 1918 is comes to mind, you know. And over the years, the process of drug discovery and development has been revolutionized, you know, and chemistry plays a significant role in this. So initially, like, you know, like I said, there are different diseases, right? And the first stage to drug discovery and development is actually the pre-discovery, you know, like you do clinical observations, you do basic research to try and understand the mechanism of how this disease progresses, like the different stages and things like that. And then you go from there to discovery. So we call this like discovery chemistry. That's where you have like your small molecules. So there are different types of drugs, right? You have small molecules. They're mostly synthetic compounds in the lab. They're less than 1,000 Daltons. So very small compounds, right? And they are mostly used. They were the first kind of drugs that were made, you know, from just synthesizing compounds in the lab. And then, but over the years, we're moving towards large molecules. So we have biologics, like monoclonal antibodies, like vaccines, you know, like proteins, right? I work in vaccines, so I'm going to touch on these. And during this stage, we use different chemical techniques. For instance, there's synthetic chemistry. So if you're an organic chemist, like Tawakat will be talking to us about, if you're an organic chemist and you have like synthetic skills, you know, you can synthesize small molecules that can make its way to the late stage in the drug discovery. And also, if you're a computational chemist, for instance, like this in silico modeling that they do to predict how these small molecules or how these compounds affect the body. And also in discovery stage, you can use computational skills to like screen maybe millions of like different compounds, and then for you to get like a hit. So the hit with the computational skills that you have with that, we reduce maybe 10 million potential drug candidates to like maybe 10, and then those 10 will enter phase 1, and then you go from there. So along this line, like I said, chemistry plays a significant role. You know, I've talked about synthetic chemistry, which is organic chemistry. I've talked about computational, right? And also you'll be working hand in hand with people that are in formulations, because you also don't just use the drug. They are mixed with things that help with efficacy and also how they are absorbed into the body, right? So you're going to work with people in formulations, which are mostly like pharmaceutical scientists, and also people that are in engineering. You know, they're the ones that make the injectables that we take in. And then along the line, we have like different phases. So we have phase 1, phase 2, phase 3, and more often than not, most of these drugs don't make it to phase 3. So you only have like a few of them that make it to phase 3, and then they are ready for filing. So this is where I work. I work in this space, So from discovery to development, and I use analytical chemistry. So separations are mostly chromatography methods, liquid chromatography, size exclusion chromatography, to support those discovery and development, work hand in hand with people that are in formulations, people that are in process, so engineers that scale up reactions. And what we do is we develop methods that can test for impurities that are present in the samples to make sure that they conform to the standards that are set by the US FDA, and then before filing. So there are a lot of career opportunities, in this field. You can contribute to drug development. There's genetic engineering, for instance, and also medical diagnostics, right? Like when COVID started, Abbott is a big company here in the US. They were in charge of like making those COVID test kits that were used to for diagnosing COVID. And I live in the US, so I've been living here for 8 years. So I like using US as an example, right? So this is like a chart showing the largest pharma companies by market capitalization as at May 21, 2024. So the latest one has increased like the value of especially these first two companies, Lilly and Novo Nordisk. So, but I want you to see that the pharma is like, it's very big. It's a hundreds of billions of dollars company. So we see that Lilly has the highest market capitalization, and then followed by Novo, and both of them, like, they're mostly known for like their diabetes and obesity drugs. So very big market. And I highlighted Lilly and Merck because I did an internship at Lilly for 4 months, and I currently work at Merck. And I've interviewed with almost all the companies on this list, like AbbVie, AstraZeneca, Amgen, Pfizer, just to show you like where chemistry can take you, like big companies, trillion-dollar companies. And also, I also want to highlight like this on the right, where you can see the cost of R&D in pharma. Research and development is very important here. Like, it's years of research that leads to production of all these drugs that I mentioned on the previous slide. So you can see that Merck, for instance, they invest like up to 30 billion annually in R&D. And then we have Roche, we have Johnson & Johnson among the big players. And what you can see is that if you decide to like choose or pursue a career in this field, like you're gonna be making a lot of money based on all this investment of these companies in R&D. So they need scientists that can come into, contribute to drug discovery and development, right? So you have highlighted there, you have biochemists, you have molecular biologists, you have clinical chemists and the likes, and you can work for the largest companies in the world if you decide to pursue a career in this field. And I also like to touch on environmental science, because when I was in Nigeria, like I mentioned Professor Shibanjo when I was in underlevel, I gave this talk, and a big picture, like if you're an IQ chemist in Nigeria, we want to do environmental because that's like where you have funding, and we have a lot of environmental problems in Nigeria. So that was the point I decided to pursue analytical chemistry. And my goal was I'm going to be an environmental chemist. It's applying analytical techniques to answer environmental problems, right? Or to solve environmental problems. So during my time at Tennessee Tech, I was really into development of analytical techniques to study polycyclic aromatic hydrocarbons, which are environmental pollutants. And at that time, they were like ubiquitous, and they were the hottest environmental pollutants in analytical chemistry. So, and during that time, I had the opportunity of reviewing a paper on oil spill identification. So in 2010, there was a large oil spill in the Gulf of Mexico in the US, and it's called the Macondo oil spill, and where I think it's arguably the largest single oil disaster in the oil and gas sector. And what happened was there was an offshore well that leaked, and billions or trillions of gallons of oil and gas was released into the Gulf of Mexico, and it led to a big environmental problem. So around 100,000 kilometers square of oil, just floating around in the open ocean. And a lot of tools were put in place, for this leak to be contained. And after 87 days, it was finally contained. But the disaster had already happened, and the damages had already been done. So a lot of people were tasked with, cleaning up the mess that had already been created, and the environmental impact assessment was also put in place. So you can see like different people. I put a picture here. You have like remote operating vehicles. They were actually involved in like mapping the ocean floor, and also like their robots that they were used to like detect where the well was leaking, and we were able to contain it. But one thing I want to show you is like the impact of, you see here we have lab-based chemical analysis, and then you have like different analytical methods here that were used to fingerprint the oil spill, and also to try and look at the biodegradation products and photo-oxidation products, biomarkers, welding products of this oil spill. Are they harmful to the environment? Are they harmful to the aquatic organisms? Because a lot of organisms were actually dead, and they had to be somewhere, some had to be relocated. And during that time, I learned about a field called petroleomics. So it's basically using mass spectrometry to analyze petroleum products. And this is the most powerful mass spec in the world. Is a 21 Tesla Fourier transform ion cyclotron resonance mass spectrometry. It's at the National Magnetic Field Lab in Florida State University, where you don't have to separate the component of crude oil. You can just inject that into the instrument. You do your sample pretreatment, of course, inject that into the instrument, and then you can fingerprint like different oil spills and things like that. So I wanted to pursue a career in that, and I thought like I should share this with you, where you can see how you can use chemistry to solve like complex problems like this, like oil spill identification, for instance. I know it's a big problem in Nigeria, and if you decide to pursue a career in this, you can work as an environmental chemist, environmental toxicologist, and you can work with the US Department of Environmental Protection. So it's US EPA. You can work with chemical companies like Dow Chemicals. And another thing in the US here that is very common, which is environmental problem, is we have this Superfund site. So this is a map of the US, and all these dots that you are seeing, they are like Superfund sites. So Superfunds are basically sites that have been restricted, they have been closed because they are heavily contaminated. So they're contaminated with perfluoroalkyl substances, PFOS. They are the hottest environmental pollutants right now. We have PHEs, we have radionuclear wastes. So because of that, they are very harmful to humans, right? They are very harmful to the environment. So they've dedicated this area to like they've conceived this area, and they call them Superfund sites. So they are very toxic. So they need people that can help remediate this area. So it's called like environmental remediation. It's another big area in environmental science that the US government is investing billions of dollars into, for people to come in and develop like maybe adsorbents, for instance, that can be used to remove all these environmental pollutants. And also the nuclear waste is another big concern here in the US, because US has the largest nuclear facilities in the world. So we have like nuclear reactors that they are used for making like radioisotopes, and also they use for generating electricity. And there's a process with recycling of this waste. So you need like adsorbents that you can use to selectively chelate the heavy metals that are present in this nuclear waste, and then recycle them. So that's another big area. And then the US government is currently moving towards like environmental sustainability due to climate change. So they're trying to like move away from all these toxic chemicals, and they need chemists that can actually help with that, writing, with pushing the environmental sustainability goal of the government. And another thing that's big is material science and engineering. So if you are interested in engineering and somehow you find yourself in chemistry, right? And you're like, that's the end of the world. No, it's not. There's actually an area that's chemistry is like I said earlier, chemistry connects all these disciplines. So you can find some form of engineering in chemistry, and that area is material science. I have friends that they currently work for the biggest engineering companies, and they only studied chemistry. So, and at my school in Florida State University, Department of Chemistry, material science is very big. So that's how I got to know about most of these things. So basically developing new materials, right? Specific materials with unique properties. And I first heard about this in my 300 level this professor Oshowale actually taught us this, that was when I started learning about nanotechnology and the likes. And you develop new materials, right? Like through synthesis or whatever techniques that you use, and they are tailored for unique applications. For instance, there are people that develop perovskites. They're the new generation of materials that people are developing right now. You can use them for photovoltaics, you can use them for photocatalysis, photo detectors, and also they're used in batteries, right? The world is moving towards renewable energy, so there's emphasis on making batteries for electric vehicles, for instance, like Tesla. So there are people that develop specifically synthesize like electrodes made from chemical substances with improved properties to be used in batteries. You have supercapacitors, you have sensors that are used in various instruments, and you also have you can also use them for in electrolysis. So the field of material chemistry combines all these different aspects in where you can make these different products, and they are used for unique applications. So renewable energy, nanotechnology, also used in drug discovery, where you deliver payloads of drug substances into like nanomaterials, and then they can be used as drug delivery vehicles. And there's also an emerging field in bioengineering where you synthesize biocompatible polymers, and then you can use this for like implants. So they use it in surgery and things like that. And there's a lot of opportunities in this area. You can work as a chemical engineer, you can work as a process engineer. There's a lot of Nigerians at Intel that studied chemistry, but now they work as process engineers. You can work as a material scientist, you can work for big companies like Tesla, Intel, 3M, IBM, and yeah, and what have you.
Yeah.
My time is up, right?
Yeah.
Okay. So just give me 1 minute. So
Of
I
course.
just wanted to show this. So this is from the IUPAC website. I got this, and just to show you like the future of chemistry. The chemistry that they were doing 100 years ago is not what we are currently doing right now. Chemistry has evolved over the years, and what we are currently active area of research right now is in making next generation devices, like wearable sensors where you implant, like put them on your skin, and then you can use that for like monitoring maybe your blood glucose level, and that can be used to monitor diabetes. Another aspect is like AI. AI is currently big in chemistry right now, and we currently use it in pharma for predicting the properties of drugs and things like that. And another thing is making sustainable polymers, polymers that you can easily recycle, to prevent global warming and things like that. So I hope I've been able to show you, sorry the time is too short, but I've been able to show you like what chemistry can really do for you, and how chemistry is intertwined with like other majors. So if you're struggling with accepting chemistry, it's actually you can talk to people, like just to show you that chemistry is broadly applicable to like everyday what we do every day. And I think I need to show this. So this was me in 2018. Sorry, the picture is not clear, but I was an intern at Beringa and Guam. And one thing I wrote here is that I am going to pursue a PhD in analytical chemistry at Florida State. That I want to explore separation science, chromatography, and mass spec, which I did. And my long-term goal is to work in a top pharma company like Beringa. Of course, I was at Beringa there, so I have to put that. But I work at Merck now. So I wrote this 6 years ago, and now I think I'm living the dream. So one thing I just want to say is, don't give up. Keep doing what you know how to do best. And I think we are going to touch on this later, where we are going to talk about like career opportunities or grad opportunities for scholarships and grad school in the US. So I think, yeah, that's all I've got to share. Thank you all for listening, and I'll be willing to take any question. Thanks.
Thank you so much, Dr. Ogunkole. That was it's very nice to see how chemistry just connects to every single thing. I just like to say chemistry is life, and you really like just shown that. And we have a couple of questions in the chat, but before we go right into that, I know that you mentioned you applied for pharmacy, but then you got chemistry, and you know, at that time in 2010 or 2011, when you saw that, how were you able to sort of still continue to pursue chemistry? How did you get through your first year and still like keep that focus and still try to do well?
I think orientation is very important. Orientation is very important. I loved chemistry, okay? And actually, yeah, I wanted to switch to pharmacy, but that didn't happen. So I think listening to Professor Oshibanjo helped me because he told me how he made a lot of money from like being consultant to all these big companies and what you can really do with chemistry. So that just filled my faith, and I was like, okay. And then I would say when I was in 20 level, I heard about opportunities in the US. So I think connecting those dots early in my college career really helped me a lot. And I was like, okay, I think I already know what to do, how to do it, and when to do it.
Awesome. Yeah, I think that's why I think orientation, just like you said, is very important. And I'm sure SCSN is doing they're doing their possible best to make sure that you have as much information as possible. Even if the information doesn't come to you, you should also try to look for the information. You could put it on Google. Oh, what are the opportunities for an industrial chemist? Oh, what are the opportunities for maybe an analytical chemist and things like that. So there are a lot of questions here, but we'll just take one and then we're going to push it all back to the panel session that we have later. So let's see. I think the first question, I think this is an interesting question. This person must be very passionate about helping save lives, but we are all saving lives one way or the other. So she's asking, or he is asking, I'm not sure, as a chemist, can I also work in a hospital?
Oh yes, I did not touch on that because like I said, I really had a short time, but yeah, so you can work anywhere actually. So in the hospital, hospitals are bigger in the US. So so I'm gonna be talking about the US. There are big hospitals that like do research, they do diagnosis. So I believe like you can work in hospitals. Like you can there are hospitals that have research facilities also. There are hospitals that have research labs where you be developing new techniques for disease diagnosis and things like that. So definitely.
Okay. Thank you so much. Thank you so much for sharing your knowledge with us today. So because of time, we still have a panel session coming. So just send all your questions to the chat and we'll do our best to respond to them. And if it's possible, some of us might be responding to them already in the chat. So I know we are doing so much chemistry, science, and serious talk. So let's just have a quick trivia time. So if you know the answer to this trivia question, just put it in the chat. You don't know, we might have a prize for you, you know. So trivia time. What do you think is the answer? Put it in the chat. Let's see. Okay. Interesting answers. Okay, I think it's water and carbon dioxide winning so far. Okay. Okay, so the right answer is actually carbon dioxide. So dry ice is actually a solid form of carbon dioxide. It's your normal ice that is a solid form of water. Well, I hope you enjoyed that one. So that's just like a little icebreaker. So let's move on to the next part of our session today, which is a panel discussion on pursuing advanced degrees in chemistry, masters and PhD programs. So the panel session is such that we're here and ready to answer any questions you have at all, whether it's what you can do with chemistry abroad, or if you can, just like someone asked, can I work in an hospital? there's that part of chemistry. I think it's kind of getting its own name now, or maybe it already has its own name, chemical biology. So I think that's like a part for someone who might be interested in working in an hospital or something like that. So for our panel session today, we have Dr. Ogunkunle, who you've just listened to, and two other outstanding individuals who also graduated from the Department of Chemistry and the University of Ibadan. First off, we have Tawakkal Tawa. So Tawa is a four-year graduate student in the field of organic chemistry and chemical biology, at the University of Tennessee in Knoxville. And our research is focused on designing and synthesizing cell-selective analogs of precursor isoprenoids to investigate the role of the isoprenoid pathway in disease progression. So you see that Tawakkalt holds a BS in industrial chemistry. I saw someone in the chat asking, what can I do with industrial chemistry? Can I do something else? She studied industrial chemistry and then did a master's in organic chemistry. And now she's doing organic chemistry and chemical biology. So chemistry is everything. I can't find any other word to describe chemistry right now. So, and she has actively shared the progress of her current research with the scientific community, presenting at 2 conferences, and we'll be giving another presentation at the upcoming Nobuche this fall. So Nobuche is the National Organization for Black Chemists and Chemical Engineers here in the US. And our work aims to contribute to the understanding of mechanism underlying the role 5-carbon-bearing isoprenoids in cell signaling and disease proliferation. You might be wondering, why am I don't want to say boring you with reading out all their profiles, but I want you to make sure that I want to make sure you're picking the points from this profile. You see, she's in the field of organic chemistry, chemical biology. She started with industrial chemistry, did a master's in organic chemistry. Now she's doing research that is closely related to sort of medicine, right? So, and then up next we have Toyib Oluokun. So Toyib is a dedicated and accomplished scholar from Oyo State, Nigeria. He's currently pursuing his PhD in chemistry. If I'm correct, he is in the field of inorganic chemistry at Tulane University, building on his academic foundation with a first-class bachelor's degree from the University of Ibadan. As a member of American Chemical Society, SMART Network, and an ISI scholar, Toyib is actively engaged in his field and committed to excellence. With a passion for academia, volunteering, and mentoring, he enjoys guiding and supporting upcoming scholars to achieve their full potential. If I were you, let's say I'm the one in the other side of the screen. The last point here says, he enjoys guiding and supporting upcoming scholars to achieve their full potential. Once this session is over, I'm just going to go to LinkedIn and look for Toyib, like, oh, can we talk? I am this and that, introduce myself. I aspire to do this and that. That is how you build relationships. That is how you form connections. That is how you get information. So, again, I'm saying a lot already, but let's just get right into it. So our topic is pursuing advanced degrees in chemistry, master's and PhD programs. So here's how it's going to go. Just put the questions you have in the chat and our speakers would be ready to answer all of it. But before we go right into answering the questions, we already heard from Dr. Ogunkunle, so I would like Tawakkalt and Toyib to briefly tell us about their journey. So Tawakkalt, do you want to go first? And in 2 minutes, I know it's a short time to say everything, but.
Hi, everyone. I'm very sorry. I won't be able to turn on my video because I literally just woke up before the webinar started, so I look very tired. So I got admitted into the University of Ibadan. Can everyone hear me?
Yes.
Okay, please let me know if I'm going too fast because like I've been told that I talk very fast.
Yes.
So I got admitted into the University of Ibadan in 2014 to study industrial chemistry, but I actually applied for pharmacy. But I mean, like every other person's, I really don't know everyone like why some other persons didn't get what they applied to study, but mine was because I didn't get up to the cutoff to study pharmacy. But you know, like yeah, I along the line I fell in love with chemistry, and I was like, yeah, this is actually not really bad. But you know, one thing I would advise like anyone going through that to like do for themselves, because the best thing you can do for yourself is actually just like, yeah, you know, put in effort and make the best opportunity of what you're doing right now. Because I believe that whatever is worth doing well, whatever is worth doing at all is worth doing well. So don't just say because you didn't get what you wanted to study and like you're not putting a lot of effort into what you're studying right now. Because at the end of the day, your GP is gonna suffer, and then you really don't know what you want to do after school. So after my BSc, I went back to study masters, and I did that on PTDF scholarship, the local scholarship, same at the University of Ibadan. And then I applied here for organic chemistry, because honestly, organic chemistry has always been something that I really, really love. Even the mechanism part that everyone found very difficult, I did with ease because it's something I really love. And I feel like the idea of being able to synthesize compounds that are not naturally occurring, I think is actually really like, it's fascinating knowing that you can make a compound that is not naturally occurring, and then you can use that to probe like a lot of pathways and like, you know, see the effects of these compounds on like, yeah, several diseases. I think it's really, really fascinating. So when I joined the University of Tennessee here in Knoxville, I joined the Bacilli lab, and I really wanted to do synthesis. But because my PI, my supervisor is a chemical biologist, it's not possible for you to just focus on the synthetic parts of the lab. So I started learning some cell culturing stuff. So basically what I do now is I make compounds, I synthesize compounds, and then I check their activity on cancer cell lines. I work with different cancer cell lines, and the journey has not been very smooth, but honestly, I've really enjoyed it so far. And like, yeah, like Dr. Gukule and Faidat has been saying ever since this webinar started, I don't think there is limit to what you can do with chemistry. So yeah, let's see if there are questions we can answer for you. I would like, I'm very sure that I will try as much as possible to like do justice.
Awesome. Thank you so much for sharing. Toyib.
Yeah, good evening, everyone. I'm Toyi Bolu Okun. Yeah, so we already had my introduction from Faidat. Yeah, my own journey, just like Mr. Ogunkule, Dr. Ogunkule said, yeah, me too. I came from a very humble background. So my journey into chemistry, I would say it's actually started during the post-UTME. I also applied for medicine. I didn't apply for pharmacy. If I applied for pharmacy, then maybe I would have gotten it. Yeah, because my post-UTME result was way above it. But what's important to me is just being successful in life, whether it's medicine, is whatever you're doing. I'm very good in mathematics, physics. That is my specialty. I would have loved to go into engineering, but my dad forced me then to go into medicine because he thinks I'm better among others, like to pursue those kind of courses. But what's important to me is just being successful in life. I went to the post-UTME. Then my dad already had some information then that if you finish with first class in UI, you will get a graduate assistant, your master will be free, you get free accommodation, you get free stipend. Those are my own motivation. Those are my motivation. So whether it is chemistry I'm studying or whatever, I'm already ready to put in the very effort. I'm a very average person in chemistry during my secondary school. So I won't say I really love chemistry like that. But here I find myself, I graduated with first class in chemistry. I just put my efforts. I remain focused. I remain focused because to me, the end result is just being successful. And that is what matters to me. So whether you get what you want or you don't, I think, or I will believe what most people also want to do is just being successful in life. Whether you want to save life or you want to be a pharmaceutical or wherever you want to work, what matters is my contribution to the world. What am I able to contribute? What people are able to gain from me, my dedication, and those are the things that really matters to me. So graduating with a first class has opened many opportunities to me. So I will say what I'm going to tell current undergraduate students is that please try as much as possible, get the best results you can get from your chemistry. It will open a lot of ways for you, a lot of ways, because your results will be like your first appearance before you start tendering, or before you start telling them, okay, I can also do this, I can also do that. It's your first appearance they're going to ask for, and it will open a lot of ways for you. Please try as much as possible. Remain focused. I know Nigeria is like very tough currently, but you can do it. Others have been doing it, and the fact is that if you are not going to like be, if you are going to be straight with the point, things are going to be much more difficult. That's the way Nigeria is. We hope it doesn't look like that. Things get better. That's our hope. But let's face the reality. So what you just need to do is to refocus your energy and get the best from what you have now. And it's a very good opportunity that you are here today. Just make use of the opportunity. Make use of the lecture, or what Mr. Dr. Ogunskle, I'm sorry, all what he has said. Please be target all those companies, be focused. You see, chemistry can get into a lot of things. So just be focused, and you get what you need, and you'll be happy with yourself. You'll be proud of yourself, and in the later.
Yeah.
That is my.
Thank you so much, Toib and Tawa, for sharing. We are almost at our time commitment, but I know there are still so many questions out there. I want to indulge and plead with our panelists and speakers to still give us some more time. Is that fine?
Yeah, that's fine by me.
Okay. Thank you so much. So before we go into answering questions, I see Professor Ganiat Oloyede is here. She's someone who taught most of us that are here, and I'm sure she's still at UI. And thank you so much, Ma, for joining us. I'll just allow her some few minutes or seconds to say something.
Hello, everyone.
Hello, Ma.
Good afternoon, Ma.
To connect with you, I'm really excited when Olatunji sent the invite to me. So I'm just happy to connect with all of you. You all doing well. Well, it's all student affairs, but then I must congratulate you on your successes so far. But what I want to say now is that you've talked much on chemistry, the advantages especially, and I want to put it to you that what in this world is not chemistry. It's no news that many of us that read chemistry actually wanted to read other courses. In 1987, when I applied to UI, I wanted to read medicine too, but my cutoff was not up to the mark, so I had to end up in chemistry. But I must tell you that today, I'm really happy that I studied chemistry because it has opened so many doors to me. You know, I'm really doing well. Apart from lecturing, I'm into a lot of other things. I'm mentoring students, you know, and currently as a career consultant with American Chemical Society. Every year I'm invited to counsel and to mentor students. So the sky is the limit for you, you know, whether you read chemistry, I've been read chemistry. And also, chemistry is also a platform. You can build up on it. When I read chemistry first degree, I was lost as to what do I do with chemistry, like so many of the questions that we are seeing on the platform now. I must tell you, it's one of my mentors that now asked me, what really was my interest at that time? And I said, I love something that has to do with drugs. So it now took me, I read pharmaceutical chemistry as my MSc, then I read my PhD degree is actually in pharmacy. So with chemistry, you can diversify into many, many other ways, whether into oil and gas, into drugs, pharmacy, you know, even chemical engineering and all the rest. So I want to congratulate all of you for this initiative. So please keep it up. Thank you very much.
Thank you so much, Ma. Thank you so much for being with us, and thank you for teaching us. Thank you for being a model to all of us. So we're going to go right into it with some of the questions. I see a couple have been answered in the chat, but I would read them out just for other people. Someone is asking, as a chemical engineer, is it limited to a person who studied pure chemistry and industrial chemistry? And would like to ask for career opportunities each for chemistry and industrial chemistry. I think Dr. Ogunkule has answered that, but Dr. Ogunkule or Emmanuel, if you want to just respond to that in 30 seconds.
Yeah. So basically, what I just want to say is there's no difference between pure applied industrial chemistry. All you need is the background. Do you have the background in chemistry? And then I know people that study chemistry, like they're now chemical engineers, you know. You're gonna take courses. If you want to do a PhD in chemical engineering, for instance, you're gonna take courses that are like prerequisites that you are supposed to take in undergrad. And once you meet those requirements, you can become a PhD candidate. So it doesn't really matter if you study chemistry, pure chemistry, or industrial chemistry. It's just the name.
Yeah, that's it actually. So another person is asking, as an industrial chemist, can I pursue a career in the field of pharmacy at master's level in both Nigeria and abroad? Yes, you can. And the first part of Dr. Ogunkule's talk was highlighting the different pharma. I know we were saying pharma. Pharma just means pharmaceutical, but we all just say pharma. So you would see that he was highlighting his journey, and he had interned in a big pharma or pharmaceutical company, but allow me to use the word pharma now. And he has interned in 2 big pharmas, and now currently he works in another big pharma, which is Merck. So yeah, and in his profile, his bachelor's was in industrial chemistry. So yes, you can. How do you go about pursuing a master's or PhD in an area of field that is different from your undergraduate research work? For instance, your final research is on inorganic chemistry, but you want to get PhD opportunities in green catalysis. Tawa, what do you think? Considering you've moved from industrial to organic, now like chemical biology.
Honestly, I don't think it's something that is impossible, because I have what's it called? I have people that we joined my university at the same time, and majority of them did not even continue in the track that they started from in UI. You see what I mean? Because like a lot of people actually did PChem, like physical chemistry. Some people did analytical in UI, and then they got here and then just switched. What they are doing currently has nothing to do with what they did in UI. So it really doesn't matter, honestly. You just have to be sure that whatever lab you want to join, the research interest aligns with what you want to do. No one really cares whether you did industrial chemistry for BSc or you did organic chemistry. It's not, I mean, it's good to have a background like what Dr. Ogunkule said, but honestly, I feel like majority of us in UI, the courses we took, they were just all the same. It's just what you have on your certificate or what you think you studied that you're carrying around. But once you get into the US, whatever lab you want to join, I don't think no one would say, oh yeah, because your certificate holds industrial chemistry, you cannot join my lab. No, at least it's not like that in my school.
Yeah, I agree with you. I mean, I don't think it's like that anywhere. It's really, as long as you're open and willing to learn. And for this person asking industrial chemistry and PhD in catalysis, I think even people that are doing research in catalysis and stuff, most of them are in inorganic chemistry. So I think you're still on the right path. Yeah, I think you're still on the right path. Okay, so what are the most in-demand jobs for chemistry graduates? Who wants to take this?
I don't want to be the only person speaking, but let me just tell you this. I think we need to organize another session about
well, you have more what is it called, experience than us.
I know, right?
Talking.
So, I see people talking about in-demand job, and I noticed this because I work with people that want to apply to the US, and I noticed with them a lot. Like what area do I need to study to get this job? See, just get a degree in chemistry. There's no I want it in like you're applying for, you want to study something because it's in demand. I don't think that's the way to go. Study
Yeah.
chemistry if you love it. Study any area that you love. You find application for it. Like I said, pharma is big in the US, right? I have someone that was my lab mate. He did like a lot of bioanalytical chemistry. He works now in like as a process engineer. You know, so it's the skills that you have that will get you the job. It's not by the name of the course or
What
the
is in demand?
exactly. So it's not by what's in demand, you know. So you are the one that will find a niche for yourself. Like, what do you really love? What do you want to pursue? And one thing I want you to know is this will change. Like in the next 5 years, I may decide I'm bored. I don't want to do pharma again, you know. So I
Yeah.
hope I answered your question.
And
Yeah.
that's actually the truth. So add to that, you know, US in most schools you have to do lab rotation. So the main thing to me is that just try as much as possible, get the good grades, find yourself into a PhD or MSc in the US or abroad, get an abroad scholarship. Then when you get there, when you graduate, you can find your feet anywhere. Then you should be good to go. And in US there's lab rotation, so you can easily join any lab you want, whether it is organic, inorganic, or whatever. You can easily do that without restriction.
Thank you so much for adding that. And if I know I'm not part of the speakers, but if I am allowed to add something too. So when someone says like most in-demand job for a particular, we all think like it's a certain professional course that has the best chance of success or things like that. Currently, I'm interning at an agri-science company, and we have people that when you're like, what did you study? And they say, oh, I have a PhD in weed science. Okay, let me ask you guys now. When you hear someone studying weed science, what comes to your mind first? You're like, what is that? I know, but weed science is so important because, I mean, people are out there making herbicides. Why are they making herbicides? To help farmers. Why do you need to help farmers? So that the global food supply or global food demand is met. You know, so you need to make sure that just set yourself up for success wherever you find yourself. Just make sure that you are trying to be like the very best. You're trying to be an expert in that field. Okay, so how do one get access to international scholarship for PhD program in chemistry, and what are the procedure needed? Toib, if you want to just keep it short, you know, there's a lot to say.
Yeah, exactly. There is a lot to say. So the main thing, just like I've been saying, try as much as possible, get the good grades, and also try to volunteer, take leadership position so that you don't have only first class or wherever the grade you are coming. It's not most times, at times, or what should I say? At times, it's not only about your grade alone. Your grade will open ways for you, but you still need some prerequisites to be better than others, because others are also bringing the same grade or something better to the table. So what make you unique? Maybe you've taken some leadership position, or you attended some conferences, you've done this, you've done that about on your feet, that makes you exceptional compared to the other candidates. Because just like anyone, a pool of applicants come and they have to pick the best. And what makes you special, what makes you be the best, that is what they are looking for compared to the others. So what I would say, after getting a good grades, your lecturers, our lecturers, we need them. You need them a lot, because you need a recommendation letter. And this is like the best time when you are still in school to mingle with them, interact with them, tell them your aspirations, tell them you'll be needing their help when they graduate. They'll be readily available to help you. But you to try and like let them know ahead, because they also have busy schedule. Then after that, there are mini scholarships to write some tests like TOEFL tests, TOEFL, GRE group. So there are some mini scholarships that can help you. All of this is just about getting the right information, and that is why you are here today. But we cannot like put in everything here today. We start telling about scholarship applications into the abroad scholarship. We will spend a lot of time on that. So there is ISI, there is OFP, there is Michael Taiwo scholarship, there is Ansar, Al Ansar, there are some others ones like that will help you to like pay for your application fee, because the cost of this journey also, after getting your good grades, after graduation, there's still a long way to go. Get what you want. Then after getting that, then things should become easier. Then also you should like start building your CV as early as possible, even at now. Like remember, it is my final year when we were about to graduate that there was a summit in UI then for finalists. That is when I started building my own CV. You can start as early as possible. CV is something you continue building. It doesn't stop. You continue writing it. You continue modifying it until it gets better. And doesn't even get better. I am sure Dr. Ogunkele is still modifying his CV by now. So, and that's exactly the fact.
Yeah.
That's how.
Yeah.
So if you have specific question, then we can like address them.
Yeah. So, you know, applying to grad school and all, I think it's a whole session on its own.
Yeah, it's the whole session on its
So possibly maybe we will talk to the SCSN UI and see if we can put something like that together again, which would be specifically which would be more specific on applying to grad schools, to PhD programs, the things that you need. And but Toyiba has done good justice to that and has highlighted most of the things you need. And I just want to reiterate something he said, which is you need to connect and network with your lecturers. You need to build relationship because you need them, not just for a reference letter and stuff. I'm in University of South Carolina. How did I know about University of South Carolina? Because Dr. Alabi actually shared it with me. And because I think University of South Carolina had reached out to Dr. Alabi to sort of tell our students about them. And she actually shared it with me. And that was how I got in contact with the grad code. And I'm now in my 4th year in University of South Carolina. So that relationship, I think it is very, very important. I see Dr.
Alabi
Alabi
wants to say something.
raising her hand.
And yeah.
I see Dr. Alabi raising her hand, so we'll just let us speak and then we'll continue.
Yes, I was going to add something on the career opportunity, the question that the fellow asked concerning career opportunities after chemistry. I was just going to say that, well, it's not really a must that you must continue to build your life along the chemistry line. I've had colleagues who have crossed from chemistry and they are chartered accountants now. I've had colleagues who have moved from chemistry to ICT and they are doing well. So chemistry is the foundation that you can build anything on. That's all that I just wanted to add.
Thank you, ma'am. Yeah.
And actually, that's the truth. To be sincere with you, I've heard of people who read medicine and at the end of the day, they didn't even practice at all. They didn't practice. They go into something else. They feel bored of the medicine or what they've passed through or whatever. So just have the foundation. Be good at whatever you want to do. Be exceptional. That is what makes you unique. Then you find your feet and you'll be happy with yourself.
Yeah, I see a lot of questions about international scholarship, so I think we need a whole new session. But how can one get access to one after BSc? I just want to let you know that most of us here that are PhD students, we did not do masters. We don't have masters. We just came directly from our bachelor's and then we started a PhD. So it is very possible to do a PhD without having a master's. Okay, trying to see more questions.
I think someone asked a question earlier about like having a tutu or something. So I don't think anyone answered that.
You want to take that?
Well, anyone can actually answer that. I just want the person to know that their question is not getting ignored.
Oh yeah.
Just miss it.
So
anyone can do justice to that, huh?
What do you think? How can someone with a tutu find their space?
Honestly, I mean, like I said, whatever is worth doing at all is worth doing well. And while I understand that not everyone can actually graduate with the first class or 2-1, I have colleagues from OAU. I don't know anyone from UI, honestly. I have 2 colleagues from OAU that finished with a 2-2 and they got fully funded offers to US. But honestly, if you are on that verge, you know that there is the probability of you graduating with anything higher than 2-2 is very, very low. I'd say probably look into some other things that you can do, like Tohib said, maybe volunteering things, or I don't know, anything that can actually boost your profile more. Because I mean, this stuff is highly competitive, and then you have people with first class and 2-1 applying to the same position you're applying to. So if you think you are if you think you are most likely going to graduate with a 2-2. I would say maybe do some other things to build your profile. But of course, like, I'm not saying the chances of you getting a fully funded scholarship abroad is 0, because like I know people that have actually gotten scholarship with 2-2.
Yeah, actually, that's the truth. It's not 0, but you have to do the hard work. It depends on you. Do you really want it? If you really want something, you will work for it. That's, to me, that's it. If you really want something, you go extra length to work to get it. For example, let's assume you've already graduated with your 2-2. And then some of the things you can do online courses. There are a lot of online courses to boost your application. Then you write all those tests, the GRE, the TOEFL, then you write them and you try and get as much a better grade in them to prove that your background, your 2-2 is not only about you. There are other things about you. So you write GRE, you write TOEFL, you do online courses, and if possible, you can like do MSc in Nigeria and get better grade in it if you are sure you really want this. People go extra lengths for whatever they want. If you really want it, then you can have it. That's my own addition. Yeah.
Please,
So
can I
then
chime in something?
Yeah,
please?
don't just apply
wanted-
for Jackpot's sake, because I know.
Oh,
I know
yeah,
you
true.
just apply because you want to leave. Because like, yeah, once you have that intention of, oh, I just want to leave this country because it's messed up. No, like
no,
once
it's,
you have
that,
kind of
that's no, it's not
you
because the
put
country
in
is
the
messed up, you
effort
just
to
want
want
to
to like,
leave.
yeah,
No.
don't do that.
That means you really, I'm talking from the aspect that you really love chemistry and you want to pursue a PhD or a graduate course in chemistry.
Yeah, because honestly, like, people can really tell. Even when people reach out to me and they're like, yeah, please, I need you to like, yeah, give me 1 or 2 advice on what to do. You can easily tell if someone is just desperate to leave.
I agree.
Honestly, you can easily tell. So please don't do stuff just because I'm tired of here, I want to leave. Leave because you really want this, because like it's not easy. Honestly, it's not easy. PhD is not beans. I'm telling you because I'm going through it.
Okay.
That's another thing about me. Like, you should find it, whatever you are doing, please try and find a motivation. Why are you doing this? Find a reason for yourself.
Yeah,
A motivation keeps you going. We are human beings. There are times you go up, you go down in your morale. So it's very, very important. Find a reason you are doing what you are doing. Don't just do things for mania, for superfluous things, like the simple reasons. Find a genuine reason.
And
There should be a
just
motivation
to
for you. Keep going.
just to add to that person asking about 2-2, something that you can do, just like you said, take online courses, or you could volunteer in labs. I think we have some research labs in UI. You could like go there and say, oh, I'm gonna be doing this and that, and you never know, you could get a publication out of that or something. So these are ways you're like building your profile. We say you build your profile to be able to like get those opportunities.
Can I chime in something, please?
Of course.
All right. Yeah. So I noticed that a lot of people are asking like the same question over again. So we probably need to like hold another session. But one thing I want to say is, so there's this thing in Nigeria that you feel like they classify people by their grade. So you can get a 2-2. And by the time you convert it to an American grade, it will actually be something. So there was my classmate that she had 4.5 out of 7. So that's close to a 2-1, right? And she struggled with that a lot. And I had to tell her that there's no difference in the US. There's no difference between having 4.5 and 4.6 out of 7. There's no first class or 2. Of course, there's cum laude and things like that. But there's no clear, I would say sometimes it can be discriminatory, you know, if someone has like a 2-2, you feel like you're not wanted. There's nothing like that here. And there are different classes, right, of 2-2 in codes. If you have like above 3.0 out of 4, it's easier for you to get in. If you have less than that, you need to do more work. I have someone that had 3.8 out of 5. That's 2-2, right? It's low 2-2. And when she did the GRE, she had 324 out of 400. And then she had 150 in TOEFL. She applied to 20 schools. She got 1 admission, fully funded. So you see the strategy, right? Apply to more schools, smash your test scores. She also has a publication. So it's just aspect of your application. They look at everything holistically. So it's not just CGPA. You can't change your CGPA, but what can you improve on?
Yeah. Thank you so much for adding that. Again, you only need 1 yes. It's just 1 yes. And just like they said, you can't change your CGPA. I mean, if you've graduated, but if you're still an undergrad now, you know, most of us, maybe we didn't have access to this type of information. We were not like forward thinking. So if you're still an undergrad, I want to say congratulations for being here today, because now you're starting to get more information. You're starting to think about what you want to do in the future. So you're starting to build that profile. For me, I always knew I wanted to like study outside Nigeria. Even I started from when I was, I think, high school. Yeah. So when I got to UI, it was from that first day I got to UI, I started building my profile, started building everything so that when I'm ready to apply in the future, it was like gonna be a bit kind of easier for me. So yeah, it's just start looking at like, look at your profile overall, just like Toyib said, create your CV, look at it overall. Oh, what can I do? Is it that? And again, it's not, they're not looking for just nerds here. They're looking for all rounders. So if you have first class in chemistry, but you did not do anything else, like you were just attending classes and having A and all, I think you need to do more. Try to volunteer, try to like do other things outside chemistry. Like we want to see you as like a full individual, you know. And you mentioned that a lot of us are asking the same questions over and over, which is about scholarships, and also we would look into hosting another session that is going to be more like focused and practical on applying for scholarships, selecting schools, GRE, TOEFL, and things like that. Because of time, we want to, bring this session to a close as soon as possible. But I hope that we've been able to share some knowledge. We've been able to answer questions that you may have. If you want to follow up with any of our speakers, I think I'll give them the floor to let you know how you can follow up with them, whether on LinkedIn and the likes. Is it okay to connect on LinkedIn, you guys?
Yeah, it's fine. Okay by me, but it can be overwhelming. I tell you, I have like more than 100 requests, so it can be overwhelming.
Oh boy.
But yeah, sure. Why not? Like, feel free to send me a DM on LinkedIn.
What about me? Can I send DM?
Just like Dr. K said, so it's overwhelming. I mean, most times I rarely go to my LinkedIn. So just once in a while, I go there, see the messages. So it's about first impression. The first impression you're going to, when you send a message to someone, your first impression matters a lot. It depends. From there, we can like take it up to some other levels. It depends. Yeah.
I
So
was
try
just
to
going
put
to
in.
mention that. Thank you for mentioning that, like first impression. So, there is a difference when someone reaches out and is like, "Oh, I'm studying chemistry. What can I do with chemistry? Chemistry is this." And someone says, "Oh, hi, I am currently studying chemistry. I have researched and seen that I can do this and that and that. I just need some guidance and advice on this and that." Who will you reply? So first
Obviously.
impression matters. So make sure that you're not coming to ask the simplest questions. There's no question that is simple. But
Do
what
your
we're
background work
do
first.
your research first. Try to like Google. There's nothing you cannot. There's even ChatGPT now. Just tell ChatGPT what is this and that and that, and it's going to tell you. But Google is there, like YouTube, go and type it in YouTube. You will see videos of people talking about these things. So make sure you've done some level of research before actually reaching out to someone. It creates a better first impression and increases the chance. It increases the chance to get a response too. So because of time, we would not take any more questions, but I think we've been answering a lot of the questions in the chat. So
I think Dr. Alabi wanted to say something.
yeah, I saw a hand up, but it's not up again.
Well, because Toyib has kind of indirectly said what I wanted to say, is the person who was talking about having a tutu and wanting to do a postgraduate program. I was going to tell the person that, well, I've had 2 cases of people who had tutu, came to UI for a master's and then ended up with a PhD grade. eventually applied to grad school in US, and they got fully funded offer. Both of them have graduated now.
So you see,
Yeah.
that's the thing. There are so many cases. There are so many like pieces of evidence. There are so many that this path that you're working, someone has walked through that path successfully. You just need to look for that person, maybe connect with them, like read about them. If I were like on the other side of this screen, something I typically do when I was an undergrad, if I attend a session, all those profiles that we were sharing, like, some of those names, I will go to Google, search for it and see, oh, how can I apply for this opportunity? This person got it when they were in 200 level. I'm in 200 level now. Can I get that too? These are ways to stand out, right? Because we've really enjoyed talking and sharing knowledge, but to give our closing remark, I'd like to invite Olatunji Oladele, who is the SCSN UI president and has been an integral part of putting this session together. I've only interacted with him maybe for 1 month or 2 months now, but I can say he is someone who is so passionate about making impact, about helping, supporting people, about, serving people, because man, it's serving us here, giving us this on a platter of gold. So Olatunji, you have the floor.
All right. Thank you very much. I'm just happy that a lot of questions that are in the minds of chemistry students are being answered. And in fact, currently in my DM, I can receive, I'm receiving messages of how insightful and how helpful the session has been. So I would like to start by appreciating Dr. Alabi by first of all sharing a Zoom session to be held by Miss, I don't know if it's Mrs.
Don't
or
say
Miss
Faida.
Badamosi, our moderator today. So it was, I think, sometimes around June. So she was to hold a Zoom session online, and I joined and I, disclosed some of the questions that are rising in chemistry students across all the levels. For some students in 100 level, they have questions like, I wanted to study pharmacy, I want to study MBBS, not give me chemistry. Like, maybe what mentality they have is probably, maybe they will end up as a chemistry teacher, which is not, because if you don't know what you stand to gain in doing something, you might take it with levity. But for 200 level students, some people might, maybe some courses, some lecturers are giving you tough time and the results are not really showing the effort you are putting in, and you're feeling like, let me just get done with this chemistry and just go and focus on something else. There are still opportunities for it. Then for finalists that, you don't even know what's next. So this session has really been able to answer some major questions. And I also want to really thank our moderator today, because yes, he all started as if it was not going to happen, but I'm really, really thrilled, and I really appreciate your efforts so much in this today, and helping us look for speakers for session. I want to especially appreciate Dr. Emmanuel Ogunde. You see, when I was reading the profile, my head was just swelling. I was like, God, like, the first thing is when you see people from permit to use the word local backgrounds making grounds in the world is an encouragement for some of us that we can also do much better than what people. When I saw the profile and I saw someone from Shaki, I was like, oh my God, I am from Ibadan and I'm a proud Ibadan boy. So it's an encouragement. I also want to thank Ms. Tawakalitu Afolabi and Mr. Toib Oluokun. Your profile, oh my God, I'm just thrilled about it. And I also want to congratulate you on the success so far. And I pray that the fact that you've been able to make sure ability to share, this session started with a coordinators or a parent that share information among yourselves. You know, some of us have access to information and some of us don't. But it's a privilege for us to have our brothers and sisters that have gone ahead of us to come down to our level and share information with us. So we are really, really grateful. And on behalf of the Student Chemical Society of Nigeria, we are saying a very big thank you for making yourselves available to share information with us. And yes, the major questions some people are asking about scholarship opportunities, we would start working towards that. And yes, we would put that in mind. And I also want to thank students from the Southwest institutions that were also available on the call. We appreciate you for making yourselves available. And we also appreciate the master students from the Department of Chemistry. And we also want to appreciate students from the SCS community. Thank you very much for joining. And to my fellow undergraduate students, thank you so much for making yourselves available. We really, really appreciate it. Thank you very much, man.
Awesome. Thank you so much, Olatunji. It's been a very, very great, I don't know, pleasure, fulfillment, everything, putting this session together, making impact, reaching people as much as possible. So the good thing is this session is recorded and we're going to put it on the SCSN UI YouTube channel. So it's going to be there for as long as YouTube exists. So you can always share this with anybody, share, watch it again. And, you know, I saw someone asking about getting the slides. So we're not going to share the slides with you, but it's better when you are looking at the slide and also listening to the talk, you know. So we're going to put this up on SCSN YouTube channel, so you always have access to it. I want to say a very big thank you to all our speakers today. Dr. Ogunkunle, Tawa, Toib. I just went into their DM and was like, oh, you guys, this, and that. And they were like, yeah, I'm down. I'm up for it. I mean, that is, you're just so selfless, and that means a whole lot. Thank you so much for giving your time. Thank you, Dr. Alabi, for everything, for making impact in so many of us, in our lives. And I can't even describe it, but you are more than amazing. And thank you, Professor Oloyede, for joining us today. Thank you, Ma, for all you've done, how you've invested in us over the years, and how you're still doing that now. We would talk to the SCSN and see how to organize another session that will be focused on applying to grad school, doing all of those kind of things. But thank you so much, everyone, for joining us, for giving us your time for the past 90 minutes. I know the time contract was 1 hour, but I mean, we had to be here for extra 30 minutes and you still stayed with us. So thank you and have a very good evening. Bye.
Thank you.
Thank you, everyone.
Bye, everyone. Bye,
Thank you.
Emmanuel. Tawa.
Thank you very much, ma, Dr. Alavi.
Yeah,
Thank you.
thanks. Is that Olatunji?
Yes, ma. Yes, ma. Thank